The topic for today is absolute value equations, equations that involve the absolute value of something. So remember how absolute value works. If I say, what's the absolute value of -3? The answer is 3. The absolute value of a negative number is the positive. What's the absolute value of +3? Answer, 3. The absolute value of a positive number is just that same number. Now, what if we had the equation, the absolute value of x equals 3? What could x be? That is, what numbers do you know of where the absolute value of that number is 3? Well, we just said what they were. X could be +3 or it could be -3, because either way, the absolute value would just be 3. So those are the two solutions to that equation, +3 and -3. For the equation absolute value of x equals 17, the two possibilities are x could be 17 or x could be -17. For the absolute value of x equals -4, now this has no solution. There's no way this could be true, because no matter what x is, when you take the absolute value, you can never end up with a negative number like -4. And if it says the absolute value of x equals 0, here there's only one possibility, and that is 0. There's no positive or negative 0, it's just 0. So here's the general rule. Whenever you see the absolute value of some expression equal to some positive number, there are two possible ways for that to be true. Either the expression that's inside the absolute value bars could be equal to that positive number, or that expression could equal the negative of that number. And on the other hand, if you have the absolute value of some expression equal to some negative number, then there's no solution. There's no way that the absolute value of anything can be negative. So that's how you solve absolute value equations. If it says the absolute value of something equals some positive number, you solve by turning that into two separate equations without absolute value bars, and then solving those to get your two solutions. And if it says the absolute value equals a negative number, then just right away you can say no solutions. So let's look at some examples. The absolute value of x plus 1 equals 7. So here the expression inside the absolute value bars is x plus 1. The positive number that the absolute value is equal to is 7. So the two separate equations are x plus 1 equals 7 or x plus 1 equals -7. Now all we have to do is solve each one of those by subtracting 1 on both sides. Here, if I subtract 1 on both sides, I get x equals 6. Here, if I subtract 1 on both sides, I get x equals -8. So those are the two solutions to that equation. Let's try this one. The absolute value of 3x minus 2 equals 17. So what can you say about 3x minus 2? What are the two possibilities? 3x minus 2 equals 17, or 3x minus 2 equals -17. Now we just have to solve each dinky little equation. So go from 3x minus 2 to just 3x by adding plus 2 to both sides, and then go from 3x to x by dividing both sides by 3. With the first equation, we end up with x equals 19/3. And with the second equation, we added 2 to both sides, and then we divided both sides by 3, and we got x equals -5. So there's the two solutions, 19/3 or -5. What about this one? Absolute value of x minus 4 equals -3. Scream the answer to me through your screen. That's right, no solution. Why? Because there's a negative number here, but absolute value can never be negative. It can never equal a negative number. And this last example is a little different because the way things are set up right now, the absolute value is not by itself on one side of the equal sign. So it doesn't fit that pattern that we've been working with. So the first thing I need to do is make it fit that pattern. So to get the absolute value part by itself, we need to get rid of the minus 11 that's not in the absolute value. And so we do that by adding 11 to both sides of this equation. That turns it into the absolute value of x equals 16. And then the two separate equations that gives us, x equals 16 or x equals negative 16. So now you know how to solve basic, linear, simple, absolute value equations. And that's pretty much as far as we're going with that. But I wanted to mention how this relates to distance on the number line, if that helps you to think about or visualize what's going on. You can think of the absolute value of a number as how far that number is away from 0 on the real number line without specifying which direction it is from 0. So the absolute value of x equals 3 means that x is a number that's 3 units away from 0. It might be 3 units to the right, or it might be 3 units to the left, but it's 3 units away in one direction or the other. So that means it could be 3, or it could be negative 3. And absolute value can be used to tell how far apart two different numbers are from one another if you don't know ahead of time which one's largest. If you did know which one was the largest, you could just take the bigger number minus the smaller number, and that would be how far apart they are. But if you don't know ahead of time which one's the bigger number, you can still subtract, but then you take the absolute value. So the absolute value of x minus 6 would represent the distance between x, whatever it is, and 6, how far x is away from 6. If I say the absolute value of x minus 6 is 2, that means that the distance between x and 6 is 2 units. So x is 2 units away from 6. Here's 6. What are the numbers that are 2 units away from 6? Well, if we go 2 units this way, we get to 8. If we go 2 units this way, we get to 4. So the two possibilities for x are 4 or 8.